In Chapter 10, we learned how pie charts and bar graphs were used to display categorical variables. When dealing with quantitative or numerical variables, the most common distribution that you might encounter is what's called a histogram. Now, a histogram at first glance will look similar to a bar graph, but there are some key differences that we need to make sure that we discuss when drawing these histograms. Typically, you would use technology to help you create these, but I want us to see how we would do these by hand first. The first thing that you need to do is you need to group your values for the variable into groups or classes. You'll notice here that the classes do not overlap. The first class ends at 7.9 and the next class begins at 8.0. You would look through your raw data and you would count the frequency for each class. So we see this data represents the percent of residents aged 65 and over in each of the 50 states. So we see that there's one state with between 7 and 7.9% of the residents are over 65, and we see none from 8 to 8.9, 1 from 9 to 9.9, 3 from 10 to 10.9, and so on. So we have data from all 50 states represented, and we've identified which class each data value belongs in. So to make a histogram, the first thing that you have to do is determine how you're going to divide the range of the data into classes. Here our data range from 7 to 18, and so we split it up into these 11 groups by counting from 7.0 to 7.9, and doing that same breakdown for each of the percentage values from 7 to 17. They have to be equal width, otherwise the graph will look distorted and can be misleading. We've counted the number of individuals in each class, and so now we're ready to draw a histogram. The only time that you should have a gap in a histogram is when the class is empty, that there's no data values in that particular class. In a bar graph, we always had gaps in between the different groups. You're going to use just the left-hand number as you go through and plot the different class values. And notice I am going to go to 18.0 because if there was a second class, that's where it would start. Then I need to have my frequencies. Now, my frequencies go from 0 to 20, so I need to make sure that I evenly space these and cover all values from 0 to 20. So I'm going to put a 10 there in the middle, and I'll count by twos. So 2, 4, 6, 8. Now you don't necessarily have to label each of the marks there, but make sure you labeled enough that you can see the pattern. So now let's draw our first rectangle. Between 7 and 8, we had 1. So we'll draw a bar that has a height equal to 1. Then from 8 to 9, it's 0, so we won't have any height there. Then 9 to 10, we've got another height of 1. From 10 to 11, we have a height of 3. And it's hard to do this without graph paper, but do the best that you can. From 11 to 12, it's 2. And then we hit 12. From 12 to 13, and we have 19. And then 8, 3, 0, and another 1. So this histogram helps us see the spread, helps us see the center, and it helps us see what the most frequent observations are. So a few things to remember when creating a histogram is that the classes should have an equal width. Some of the recommendations are to have between 10 and 20 classes, but fewer than that is common when the size of the data set's pretty small. If you don't have enough classes, if you have too few classes, then you'll end up with what's called a skyscraper. And what I mean by that is you're just going to have a couple really tall bars, and that's just not going to tell you a whole lot. On the reverse side of that, too many classes will create a pancake. And what's happening there is you split your data up too much that all you have are these little tiny bars that kind of spread out like a pancake. Actually, drawing a histogram by hand is not the most important thing that I want you to do. Like I said, you'll usually use technology if you are having to create one of these by hand. But the more important thing is to be able to interpret a histogram. What are some of the things that you should see when you see a histogram? You should be able to get that overall pattern. You should know that Jurassic Park is about dinosaurs. And if you don't know what I'm talking about, you need to go back and watch the intro video. So you look for an overall pattern, and also for any striking deviations. Do you see anything that really is different from the rest of the pattern? Sometimes you'll have what's called an outlier. And an outlier in any graph of data is an individual observation that falls well outside the overall pattern of the graph. When you're describing the overall pattern, however, you would not include any outliers in your description. You would describe what's happening with most of the values, and then you would indicate that there is an outlier that needs to be acknowledged. So what do you describe when you're describing that overall pattern? Well, you need to describe the center and the variability. What seems to be the center value, and how spread out is it from that value? Also, you need to be able to describe the shape. So an example here, we look at the same data from before. This is our histogram that was created with technology for the percentage of residents 65 and older. So the shape here, we would call this a single peak, because you just have this one peak here in the middle. Sometimes you'll have data where you have multiple peaks, and so you would indicate the shape with how many peaks you saw in your data. You also would describe whether it's symmetric or skewed, and we'll talk about skewed here in a second. But symmetric data means that it's relatively the same on both sides of that center. So here, it's certainly not perfectly symmetric, but it's not extremely asymmetric. So this one, maybe you would use the word approximately symmetric to cover yourself a little bit. Now the center would be that midpoint. What's the middle value here? So the midpoint seems to be close to about 13%. So that would be our center. And in the next section, we'll learn how to describe the center with a numerical value. But for right now, you should just be able to identify that the center does seem to be around 13%. And then the variability here, you would describe how the data is spread among the values. And so most of the data falls between 9% and 18%. We certainly have that small value that's there at 7, but that's considered an outlier, and so most of the data is there in that other mound. So describing the shape, the center, the variability. Is it single peaked or are there multiple peaks? Is it symmetric or skewed? And how is the data centered and spread out? So let's define that word symmetric and skewed. So you have a symmetric distribution if the left and the right sides of the histogram are approximately mirror images of each other. You would have what's called a skewed to the right graph if the right side of the histogram extends much further than the left side. It's going to look something like that. So you'll have some peaks over here, and then it just kind of lingers towards the right. A distribution is what's called skewed to the right skewed to the left if the left side extends much further than the right side. So you have a few small values here on the left, some low values, and then the bulk of the data is there on the other end.